Hi, welcome back. In this video, we're going to take a look at the properties that you are learning about in Newton, and these properties are also on a handout that we got in class last week. So the properties in Newton, it says properties of sigma notation. That isn't quite right. These are in sigma notation. The properties are written in sigma notation, but they're really just properties of finite sums. It's just arithmetic, but it might look new to some students if they're not familiar with sigma notation. So this list of properties is, you're going to have to use it over and over again in your assignments, and you'll use them next semester in Calculus 2. And they won't be given to you on the final because these are properties you already know. You just need to get used to writing them and recognizing them in sigma notation, and that's what your homework is for, to get practice doing that. But let's look at a couple of these properties and see why they're so familiar. So the first one, property 1, this is just multiplication. Multiplication, remember, is repeated addition. So let's look at what it says. Let's look at the left side. The left side says the sum as I goes from 1 to n of the number c. So the number c doesn't have an I in it, so that means that the terms don't change. There's just n of them. So written out, this sum is c plus c plus c dot 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 plus c. There are exactly n terms that are identical. So it's just n times the number c. And that's what the equation says. So let's look at the second one. The second one is actually just the distributive property in disguise, just written in sigma notation. So let's look at why this is the distributive property. So if we write out what the left side says, it says the sum as I goes from 1 to n of c times a sub I. What that means is each term has the same c in it, but the a's change. So it's c times a1 plus c times a2 plus dot 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 c times an will be the last term. All the a's are different, but the c's are the same, so we can pull the c out and just multiply it by a1 plus a2 plus a3 plus up to an. And now we can write that sum, that finite sum, those n terms added together in sigma notation. So we get c times the sum from 1 to n of a sub I. So that's the distributive property. The last three properties are all just different versions of the associative property of addition. The associative property of addition says you can reorder the numbers that you're adding together. As long as there's a finite number of them, you can reorder them, add them in a different order. So let's just look at one of them. Let's look at the fourth property, number 4. That one is the sum as I goes from 1 to n of ai minus bi. So it's a sum. It has n terms in it, but each of the terms is a difference, ai minus bi. So let's write out what it looks like. So the first term is a1 minus b1. The second term is a2 minus b2. The third term is a3 minus b3. And it goes on to the last term, an minus bn. So notice we can take away those parentheses and write all the a's first, right? And then write all the b's, but the b's are being subtracted. So it's minus b1, minus b2, minus b3, up to minus bn. And now, using the distributive property on the b's, we can group all the a's together, a1 plus a2 plus a3 up to an, and group all the b's together, but pull the minus sign out front. So it's minus the sum of b1 plus b2 plus b3 plus dot 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 bn. And now we can rewrite each of those sums using sigma notation as shorthand. So it's the sum from 1 to n of the AIs minus the sum from 1 to n of the BIs. And that's it. So, and you can do the same thing with property 3 and property 5. Just rewrite what the left side says. Just write it out, expand it. Then just regroup the terms and then write them in sigma notation. So let's look at how to use these properties. Let's look at an example. This is from Newton. So this one says, suppose you have two sums that are given to you. The sum from 1 to 45 of AI is equal to negative 12, and the sum from 1 to 45 of BI is equal to 10. And you're asked to compute the sum from 1 to 45 of the difference, negative 16 AI minus 6 BI. So we're going to have to use a couple different properties here. So let's write out what we're trying to find. The sum from 1 to 45 of negative 16 AI minus 6 BI. So first we can use that fourth property that we just looked at. It says the sum of a bunch of differences can be written as the difference of two sums. So let's apply that to this sum of differences that we have. We can rewrite it as the sum, I goes from 1 to 45, of negative 16 AI minus the sum, as I goes from 1 to 45, of 6 BI. And now we can use the distributive property on each of the two sums that we have. So rewrite the first one as negative 16 times the sum from 1 to 45 of AI. And the second one, pull out the 6, and we've got 6 times the sum from 1 to 45 of BI. And now we can use the two sums that we were given. So we've got negative 16 times negative 12 minus 6 times positive 10, and that gives us 192 minus 60, or 132. So we used a couple of different properties, broke it down step by step. All right, let's look at one more. So in this example, we're given the two sums and asked to compute another sum. So look at the two sums that were given. Now notice the index I on the first sum. I goes from 1 to 120. And in the second sum that we were given, I goes from 44 to 120. So the first sum is a sum of all 120 terms, all the AIs, there's 120 of them being added together. But the second sum, it has the AIs, it doesn't have any B's, but look at how many of them are being added together. We're just adding together the last 77 terms of that 120 term sum. So it's just a portion of the sum. And then look at what we're asked to compute. So what we're asked to compute is the sum from, as I goes from 1 to 43, of negative 4 times AI. So this is the first 43 terms, but each of those terms is being multiplied by negative 4. So it's slightly different, but we can work with it. So let's write down what we're asked to find, the sum from 1 to 43 of negative 4 times AI, and break it down step by step using properties. So the first property we can use is the distributive property that says we can pull that negative 4 out in front. So it's negative 4 times the sum of the first 43 terms. And that's good. How do we get the sum of the first 43 terms from the sum of all 120 and the sum of just the last 77? Well, let's look at property 5. It's one of the associative properties. Property 5 says if you're adding together n terms, the sum as I goes from 1 to n of AI, well, that's the same as first adding together the first m terms, and then adding together the last n minus m terms, and then adding those two sums together. So we can just group the sums. Now we want to get the sum of the first 43 terms. So we want the sum as I goes from 1 to m of a sub I in property 5. So we want to get that by itself. Well, let's subtract the sum from m plus 1 to n of a sub I from both sides. So we can isolate the sum of just the first m terms. So what we get on the left is the sum from 1 to n of a sub I minus the sum from m plus 1 to n of a sub I. And on the right is what we wanted to isolate, the sum of the first m terms. So let's apply what we got here to the sum that we have over on the left. The sum, negative 4 times the sum from 1 to 43 of a sub I. So we can rewrite the sum from 1 to 43 of a sub I as the sum from 1 to 120 of a sub I minus the last 77 terms, so the sum from 44 up to 120 of a sub I. And now we can use the two sums that we were given. We were given that the sum of all 120 terms was negative 2, and we were given that the last 77 terms added up to negative 19. And now we get negative 4 times positive 17, which is negative 68. All right. In the next video, we'll look at the theorems that give us more properties of finite sums. I'll see you there.